This lesson is going to be very similar to the 7.3 area of a sector formula. Only difference is we're dealing with arc length. Arc length, let me back up. An arc is what we call a portion of the circle. So this piece right here, you cut a circle, like the crust of a pizza or whatever, that's an arc. So when we're trying to find the length, it's related to the circumference. Imagine drawing a circle where you have, just draw a new circle here. You just have a portion of that circle. If I want to know the whole length around the circle, I would use the circumference, 2 times pi times r, or pi times the diameter. But if I just wanted to know a little bit about it, maybe from here to here, I would really just need to know 2 things in that circle. 1, I need to know the radius still, just like I do for the circumference. So I'd have to know the radius or the diameter. And 2, I have to know the angle at which that forms from the center of the circle to opening up toward that arc. So that angle we'll label theta here. This is this Greek symbol theta. We're going to say, okay, well, it's out of 360 because there's 360 degrees in a circle. So just like in the last formula, we had that angle over 360 times pi r squared. This is angle over 360 times 2 pi r, the circumference. We're going to do the same thing, same setup to get our examples. So let's go ahead and do a couple. Do 3 examples here. Let's look at example 1. A piece of pizza is 14 inches along its edges, which form a 68-degree angle. Approximately how long is the crust? So I want to know this length here, x. So if I want to know that length, this 14, that's going to be the radius. Picture this just being a circle that, pizzas typically are in circles. So just imagine this is going to keep going around forever. And this is going to be your radius, 14. So our radius is 14. We already have the angle. That's going to be 68. So we got everything we need to plug in to find x. It's going to be the angle, 68, out of 360, because the whole circle is 360 degrees. And then you're going to multiply it by the circumference, which is 2 pi r. 2 times pi times 14. So we're going to put that right in. You should just call that L for length. So our length is going to be whatever that equals. So 68 over 360. And then right arrow and go multiply by 2 pi and 14. So it's, let me put that multiplication there. I don't think that changes it. Yeah, so it's about 16.61 inches long. So I'll say 16.6 inches. So the length is 16.6 inches, approximately. I'll put a little approximate symbol because it is rounded, but that'll be good enough for our slice of pizza. Big piece of pizza, right? Let's look at example 2. Example 2, a central angle of 130 degrees intercepts opens up toward an arc of a circle. If the diameter of the circle is 18, what's the length of the arc? All right, so let's picture the circle. You got 130 degrees, so that's pretty big angle. That's an eyeball estimate there. An arc of a circle, the diameter of a circle. So our diameter is the distance across. That's going to be 18. So the diameter is 18. What is the length of the arc? So what is this distance here at which the 130-degree angle opens up toward? So let me look at that in red. So what is that distance here? Well, again, 130 out of 360. But it's times 2 pi r. So remember, the circumference is either 2 pi r or pi times the diameter. Those are the same thing. So whether or not you cut that 18 in half, you could do pi times 18. Or you could say, all right, well, the radius is going to be 9. So I could do 2 pi times 9, but 2 times 9 is 18. So it's really the same thing as 18 times pi. So I'm just going to say, all right, the diameter is going to go there. 130 over 360 times pi times 18. I'm ready to calculate that. And we get approximately 20.4. So our length is approximately, and I'll round it to 20.42 centimeters. So I'll go 2 decimal places out. Usually we're asked to round to 1 or 2 decimal places, so I'll go out 2 spots this time. Okay, let's do one more example. Read through this and try it on your own. And then you can unpause it when you've done. All right, let's see what we got. So we have a door opening up. All right, classic architecture. You always have to have kind of accommodate for a door. Usually there's a door stop, but let's pretend the door opens flush up to the wall and there's no need for a door stop or anything like that. We got a width of the door right there, and that's going to open up this way from the wall. So it's going to be, we're trying to find what is that length the door travels. All right, what is that? Well, we don't have a degree, but we do know that this 30 is the radius. Because if you think about this being a continuous circle, right? Imagine the door swings all the way around. Then that door represents the radius. So the radius is going to be 30 inches. Okay, so we don't have an angle degree listed, but I want you to just think about this, all right? Two walls come together typically at what angle? What angle do two walls come together at? If you thought right angle, a right angle is 90 degrees, your angle is 90 degrees, or it's a quarter of a circle. So you could do 1/4, but 90 out of 360 is a quarter of that circle. So you could do 90 over 360, or 1/4 multiplied by 2 pi r, so 2 pi times 30. So that length, that value of x there, I'll call it x since it's called x, is 90 over 360 times 2 pi 30. And so that distance is about 47.12. So the length the door travels is approximately 47.12 inches. And there you have it. There is your lesson.